Donna. Can we cue the lights, please? Alright, what's up, dogs? What's up, dogs? I'm going to start by asking all you guys a question. What does an iPhone and H-Pets have in common? Caller ID. Alright, you guys aren't laughing too loud. That's probably because you don't know what my project is yet. So let's get into it. I want to start by introducing my team. Myself, Tom, Tim, Anderson, Erica, and Ryan. Anderson, what's going on, man? Now I'm getting the last word.
They're also not with us.
Okay, so we're planning on making a play-proof device that will automize pet feeding and also improve your pet's health. Next. So, pet feeding can be a little bit of an inconvenience to business professionals that have to work late. So our plan here is to advocate to those people that can't always make it home on time. So as engineers, we plan to make an automated pet food system that will feed your pet and not only feed it, but make it healthier in the time.
Just a brief overview. So what we're making again is an automated pet food dispenser that's aimed at optimizing your pet's health while at the same time making your life easier. Our customer contact works in cognition. His name's Fabio. And the final state of the project is that it's fully functional, as you see in the video that precedes.
Oh God. Oh no. I forgot to feed Rhett. Alright, I'm just gonna sign into my account real quick. Okay. I gotta set the time to 2:03. He loves that time. Okay, you're getting kind of fat though, so only 130 grams for a day.
Do you need the handle number? Yeah.
So, how should an automatic pet dispenser work? What are the type of requirements for this? So first we have a mechanical device. So for this we have a bin to store the electrical components as well as the Raspberry Pis, the RFIDs, the scale, and the motor. We also have a separate compartment for the food as well to avoid contamination. And last we have a hopper which will ensure proper dispensing of the food. Next we have the device. So we have a central hub, which is the Raspberry Pi, which controls all the peripheral devices, and we have software as well to ensure that accurate food dispensing is maintained. Last, we have a mobile device, mobile application, where the customer can interact with the physical device itself by setting the feed signs as well as the feed amounts, and user can look at the statistics for the individual pets as well.
Okay, so Tom and I worked on the mechanical system. It features a motor-controlled hopper that dispenses whatever quantity of food the user specifies. Currently, our storage unit holds about a 10-pound bag of dog food, and the embedded system that we feature listens for weight changes in the scale that it reads. So this is the encasing, pretty accurate depiction of what our device looks like. Our back bin holds all our electronics as well as our dispenser and motor, and our storage unit. The front bin holds our food bowl, which sits on top of the scale, and this faceplate that we have, everything fastens into that for a low center of gravity, so no pet's gonna knock it over.
So I know you guys have been hounding for more, but I'm back. I want to talk about the canister. It's a Zebra. We cut it with a laser, and we connected it to a PVC pipe by machining a piece that drops down past the spinner and sucks into this PVC pipe. Can we advance to the next slide? Above that is a storage unit. We'll filter in the food into that canister, and below that, we don't have a picture of it, but it's a mount that will set the motor in place with a set screw so it doesn't turn, and we can properly dispense the food.
I do not have any dog puns. So I worked on the mobile application version of the project, and so when I was working on it, I wanted to focus on three main things. Those were personalization, a seamless login and sign-up process, and visual statistics. For personalization, we really wanted the user to be able to specify things like the pet weight, the pet age, things like when I want the pet to be fed, and how much it should be fed, etc., so that we could really analyze their statistics better and get their pet fed on time. Moreover, we wanted the sign up and login process to be very seamless so that the user can be signed up in under 3 minutes. And if AWS can send me email quickly enough, that generally happens on time for the confirmation. Lastly, we wanted the visual statistics to be visually appealing and easy to understand.
Alright, so let me walk you through how the common actually works. So there are 4 components controlled by a central hub to Raspberry Pi. So firstly, Raspberry Pi pulls the DynamoDB database once every 3 hours to update the current list of user set times, as well as the current feed amount. So once the current time matches up with the user set time, the scale is pulled to look at the current weight. The current weight is now within a certain margin of error of the feed amount, then the motor starts spinning and food starts dispensing. Motor spins for half a second, then it pulls the scale again. Process repeats until the current weight is within a certain margin of error of the feed amount. And lastly, the RFID scanner will start scanning for any local RFID tags which should be attached to the collar of a pet. So this functions as when a pet comes to eat, timestamp of the pet or when it came to eat will be punched into the database, and this will be shown in the statistical side of the mobile application.
Okay, so that's a circuit, and that basically just summarizes our entire electrical components of our project. Basically, we have our power source, which is 12 volt, 2 amp. It's connected directly to the machine. That powers the motor, which is also 12 volts, uses about 0.07 amps, a very small current. We control that by sending a signal from the Pi to the motor, to a transistor in the circuit that and then turns on the motor. We had to use a voltage regulator to step down the voltage in order to power the Raspberry Pi as well. And also, we needed enough current and voltage in order to power all the peripherals that would be attached, such as the scale and the RFID that are connected to the Pi.
So this is Fabio, our customer, and though he might not look super happy in this picture, he was actually very happy with our installation process. So that starts when the user would actually theoretically purchase the device. There would be a 16-digit machine ID and a 16-digit pet ID on RFID tag. Those will be loaded into the mobile application on sign up. So we ask for details like that, the machine ID, pet ID, as well as pet name, when you want the pet to be fed, etc. And so it's really explained out to the user in a very sequential process, and it's very easy to understand what's going on.
Thank you.
Question about, I don't know if I picked up on this or not, are you able to like schedule out like daily, or is it only just when you set it, it'll hit once and go on from there?
Yeah, so you can set it daily. So basically how it works is that you would set a time, and every day at that specific time it would dispense. You can also add and remove times, and you can do it multiple times a day if you want that as well.
I have a rough question that I've been scratching at for a little bit. Sorry, it's infectious. So I noticed that you manually set the amount of food that I feed my dog. I actually have no idea how much I feed my dog. I feed the bowl. Like, how do I, like, it's like 1/4 of the bowl, but how do you calibrate that? Like, you use it like the...
Yeah, what are you doing?
Part of the bowl. But like, seriously, like, how do I calibrate like how much I feed my dog based on what I want?
Sure, so basically we actually have a scale as part of the device. So when you initially would start up the application, you could just pour the amount of food that you would usually feed your dog onto that scale, see what the scale reads, and then you could just feed that into the
there's no like calibration to help me. Like, I mean, he just pointed out like I probably am killing my dog. Like, you don't have like a calibration.
We don't have that yet. That would probably
Okay.
be something useful in the future.
Other dogs would not be used. You just take a trash can filled with your dog food.
Any jokes from the audience? EJ.
I'm gonna be really disappointing. I don't have a joke. So if you are, so what if it runs out? Do you guys have any way of notifying or telling that it's run out?
So currently, if it runs out, the motor will spin for, let's say, a few seconds, and it will notice in software that the weight hasn't changed. When that happens, that in the future, we will notify the app that, oh, since the motor has been spinning, nothing's been changing in weight, you've run out of food.
Kyle.
How hard is this to knock over? Like, say you have like a Bernese Mountain Dog and it decides that he knows what food wants and it's just gonna go for it. Like, how hard is this to break over?
Whoa. This is gonna be rough. I don't want to start barking up the wrong tree here, but I'm a pretty strong dude. I had a tough time budging this thing. It's easy to carry for a user, but we actually added a base plate to the bottom that's going to connect the two pieces, and it acts as a very low center of mass, so even big dogs will have a tough time moving it.
David.
What happens if you have multiple dogs? Like, how would you prevent one dog from, eating the other dog's food at the same time?
Exactly. So for right now, we've designed this for just...
Question? Tom, would you repeat the question?
Yeah, so he asked about a multi-pet home and how that would work with this device. For right now, that's a little beyond the scope of what we designed. We were designing for just one pet right now as far as like other dogs eating other foods. That could be something that could be discussed in the beta version of the project.
Yeah, I have a question. And what was the final cost?
So final costs ended up being somewhere in the $200 ballpark range, maybe a little more, but that was just because of like some experimental errors at the start, and buying pieces individually is always more expensive. So when mass produced, it would become a good deal cheaper.
Joe.
What benefits does your dispenser have over commercially available products that also connect to your phone?
Oh, that's good. A good point. So ours is pretty. Yeah, I'll repeat the question. So he's asking how our product differs from other products that connect to mobile devices. Ours is kind of more all-encompassing. Not only does it weigh the food that dogs are eating and that sort of stuff, but our mobile app also has the user input food breakdown. So now we can keep track of carbohydrates and proteins and calories of specific foods. So we can make inferences off those data and tell you like, hey, if your dog is older, maybe not give it as much proteins per se.
All right, thank you.